This is Mr. V. Giriraju, Professor of EC Department, AS Engineering College, Hyderabad. So today I will explain random noise generator. So in the last video I have given explanation for the function generator, sine and square wave generator, square wave and pulse generator, and arbitrary wave waveform generator. So before going to start a random noise generator, once again I will recall the previous video topics. So actually, with the help of oscillators, you can generate sine wave. So that means your sine wave generator is a combination of the oscillator and attenuator. So with the help of oscillator, we can generate output in the form of sine wave. So combination of the set frequency and attenuator set level, so is called the sine wave generator. So now by the using sine wave amplifier and Wien-Bridge oscillator, square wave shaper, you can generate waveforms in the form of sine wave and square output. Actually here Wien-Bridge oscillator generates a sine wave. So with the help of function switch, you can choose, that means you can modify output of the sine Wien-Bridge oscillator in the form of sine wave or square wave, so according to our requirement. So actually here you have to take output to the push-pull amplifier. The low output the impedance is 600 ohms. So by the using Wien-Bridge oscillator, so you can generate sine wave and square wave according to our requirement. So by the changing position of the duty cycle, so that is called square and pulse generator. So actually here for square wave you should maintain duty cycle 50%. So 50 above 50 and 90, that is called the pulse wave. So by the changing value of the duty cycle, you can modify signal in the form of either square wave or sine wave, so according to our requirement. So next I am going to explain function generator. I think everyone knows idea about the function generator. So actually your function generator is a device so that can produce various patterns of voltage at a variety of frequencies and amplitudes. With the help of function generator, you can generate sine wave, triangular wave, and pulse wave, so like that. So pulse wave means square wave. So with the help of upper current source and lower current source, so you can change position of the current levels. So with the help of integrator, so you can generate triangular wave, and with the help of triangular wave, so you can make some modifications. Finally we'll get our required sine wave, square wave, and triangular wave with the help of function generator. So in the last class I have given explanation for the function generator. So I have given some video also. Now today I am going to explain random noise generator. So actually here the use of random noise generator, so the instrument offers the possibility of using a single measurement to indicate performance for a wide frequency band instead of many measurements at one frequency at a time. So actually in this block diagram, so first block we are having noise source. So the lies between the frequency 80 to 220 kilohertz. So this is the basic block diagram for the random noise generator. So now, so here the spectrum of random noise covers all frequencies and is referred to as a white noise. So white noise means having equal power density at all frequencies. An analogy is white light. Actually here white light is the combination of the different types of colors. So actually I already know the idea about primary colors. Here blue, red, green are the primary colors. Mixing of all primary colors, so we will get the white color. So the power density spectrum tells us how the energy of a signal is distributed in frequency, but it does not specify the signal unequally, nor does it tell us very much about how the amplitude of the signal varies with time. The spectrum does not specify the signal unequally because of it contains no phase information. So actually a spectrum will give idea about the all color wavelengths frequencies, so like that. So here the method of generating noise is usually to use a semiconductor noise diode, so which delivers frequencies in a band roughly extending from 80 to 220 kilohertz. So here the output from the noise diode is amplified with the help of amplifier and heterodyne down to the audio frequency band by means of balanced symmetrical modulator. So the filter arrange controls the bandwidth and supplies output signal in three spectrums. Three spectrums choices like as white noise, pink noise, and Isasi noise. So actually, from this figure, it is seen that white noise is flat from 20 Hz to 25 kilohertz. So actually, this is the white noise. You can observe like this. So this is start from 20 Hz to 25 kilohertz up to here 25 kilohertz and has upper cutoff frequency 50 kilohertz with a cutoff slope minus 12 dBs per octave. So here pink noise is so called because of lower frequency, have a larger amplitude similar to red light. So pink noise has a voltage spectrum which is inversely proportional to the square root of a frequency and is used in bandwidth analysis. So USRC noise ranging simulates the energy distribution of speech and music frequencies. So and is used for testing audio amplifiers and loudspeakers. So this is the use of the USRC noise. So actually in this figure you can observe so characteristics of the white noise and USRC noise and pink noise. So you can observe so like this. So our next topic, video pattern generator. So this is a basic block diagram for video pattern generator. So actually your video pattern generator, a pattern generator provides video signals directly and with RF modulation. So on standard TV channels for alignment, testing and servicing of TV receivers. The output signal is designed to produce the simple geometric patterns like vertical and horizontal. So and some designed checkerboard patterns and cross hatch, etc. So once again I will tell you, the output signal is designed to produce simple geometric patterns like vertical and horizontal bars, chessboard pattern and cross hatch. So these are the output signal to design to check output of the video images. So these patterns are used to linearity and video amplifier adjustments. In addition to this FM sound signals is also provided in pattern generators for aligning sound sections of the receiver. So observe here, we have some frequencies also. Actually, with the help of tone generator, FM modulator, and some channel carriers. So you can observe audio sections also. So actually this generator employs two stable chains of multivibrators. So observe here. So actually this having vertical bar generator. So this is the one type of multivibrator. So actually is also divider and shaping circuit. So next you can observe one more horizontal bar generator, multivibrator, divider and shaping circuits. So actually here multivibrator dividers and pulse shaping circuits, one below the line frequency to produce a series horizontal bars. So and another above 1500/625 Hz to produce vertical bars. The signal are modified into short duration pulses, which so when fed to video section of the receiver along with the synchronous pulses trying produce fine lines. on the screen. So observe here we have different types of patterns. First one is the vertical pattern. So with the help of vertical bar multivibrators you can generate like that. And another section you can observe horizontal bars. With the help of horizontal multivibrators you can generate this type of pattern. So your multivibrators produce square wave video signal at m times horizontal frequency to provide m vertical black and white bars. So after every m cycles, the horizontal blanking pulse triggers horizontal, so what triggers the multivibrator of synchronizing the bar signal on every line. A control on the front panel of the video pattern generator enables variation of multivibrator frequencies to change the number of bars. So similarly, square wave pulse derived either from 50 Hz mains of from the master oscillator are used to trigger another set of multivibrators to generate square wave video signals that are n times the vertical frequency. See here. So on feeding the video amplifier, these produce horizontal black and white lines or black and white bars. The number of horizontal bars can also be varied by the potentiometer that controls the switching rate of the corresponding multivibrator. The bar pattern signal is combined with the synchronous and blanking pulses. So in the video adder to produce composite video signal before being fed to the modulator. The provision of switches in the signal path of two multivibrators enables the generation of various patterns if both MH and NV multivibrators enable the generation of various patterns in the form of horizontal, vertical, chessboard and cross hatch. So here vertical bars are produced and with only the NV switch on, horizontal bars are generated. With both switches on, cross hatch pattern so will produce so this one. So actually here for vertical section this vibrator generates uh, bars in the form of vertical and horizontal it generate horizontal lines. So when the on both vibrators in that case you will get cross hatch pattern produced. So here the horizontal bar pattern is used for checking vertical linearity. These bars should be equally spaced throughout the screen for linearity. Similarly, the vertical bar pattern can be used for checking and setting horizontal linearity. With the cross hatch pattern, this is the cross hatch pattern formed by the vertical and horizontal lines. Linearity can be adjusted more precisely because of any unequal spacing of the lines can be dis discrant. That means here precisely means sharply and immediately generate the wave. So your picture centering and aspect ratio can be checked with the cross hatch pattern by counting the number of squares on the vertical horizontal sides of the screen. The video test pattern generator can also be used for detecting any spurious oscillations in the sweep generation circuit, interaction between the two oscillators, Four interlacing, and barrel and fin cushion effects. So here modulate fixer signals are available on the limited channels for injecting the RF section of the receiver. Similarly, an FM sound signal with a carrier frequency 5.5 MHz plus or minus 100 kHz modulated by a 1 kHz tone is provided for aligning sound IF and discriminator circuits. So a 75 divided by 300 ohms VHF balloon is usually available as standard accessory with the video test pattern generator. So this is the overview of the video pattern generator. So now I will show video on video pattern generator. So this is the video. So graphic user interface UPG monitor. So you can do like this. So this is explanation for video pattern generator. So now I am going to explain differences between the wave analyzer, spectrum analyzer and harmonic distortion. So like that, here we have so many type of analyzers are there. Now I will differentiate one by one. So already you know the idea about spectrum analyzer and harmonic distortion analyzer. So now I will differentiate spectrum analyzer and harmonic distortion analyzer. So already you know the function of spectrum analyzer. So actually a spectrum analyzer is an instrument designed to provide graphical display of the spectrum of frequencies on the CRT with amplitude of signal versus frequency. So that means amplitude on y-axis, frequency on x-axis. So this is the first function of the spectrum analyzer. So actually by the using CRO, you can measure frequency amplitude in the form of time domain. So that will give graphical representation in the form of waves. So here we can see output values of the circuit in the form of frequency domain. That means here this instrument designed to provide graphical display of the spectrum of frequencies on the CRT with the amplitude signal versus from frequency. So your amplitude will focus on y-axis, frequency on x-axis. So finally you can observe our required output in the form of bar lines. That means that will show only amplitude values. So next one, first separation of harmonic distortion analyzer. This is actually your harmonic distortion analyzers are designed to measure the total harmonic content present in a distorted or complex waveform. So for example, sine wave. Your sine wave is also an example for the complex wave. So actually that having some harmonic levels, harmonic components. So a combination of the all harmonic components is called sine wave. That means suppose we got some distortion, automatically that will be disturbed. So now with the help of harmonic distortion analyzer, we can measure such type of values. So that's why we are written here. Harmonic distortion analyzers are designed to measure the total harmonic content present in a distorted or complex waveform. And second one, in spectrum analyzer, they indicate the amplitude of all the frequency components. That means here you can express all the amplitude values of frequency component in the form of amplitude. So in the harmonic distortion analyzer, they do not indicate the frequency and amplitude of each component wave. They do not indicate the frequency and amplitude of each component wave. Actually, in the harmonic distortion analyzer, by the changing fundamental frequency, so you can change position of the harmonic levels also. So whereas in spectrum analyzer, so they indicate the amplitude of all frequency components. So third point, in spectrum analyzer, frequency range is typically from 1 MHz to 40 GHz. So whereas in harmonic distortion analyzer, these are operated within a band of 5 Hz to 1 MHz frequencies. So is also depending upon design of the analyzers. That may be the spectrum analyzer, harmonic distortion analyzer. So whatever the analyzer, so with the help of design frequencies, you can change position of the working process also. So next, in spectrum analyzer, a calibrated graphical display provided an on CRT screen of spectrum analyzer. A calibrated graphical display provided on CRT screen of spectrum analyzer. So actually here spectrum is also spectralism, spectral analyzer also having CRT screen. So on that screen we can display our calibrated output in the form of graphical representation. Whereas in harmonic distortion analyzer there is no graphical display and CRT for harmonic distortion analyzer. So actually here you have to check output of the harmonic distortion analyzer with the help of some methods. So like as Wien-Bridge method and network method, resistance method, so like that. So with the help of these methods you can observe output in the output waveform in the form of some values. There is no, that the reason there is no graphical display. So next point, in spectrum analyzer does not have any meter indicate the output. Spectrum analyzer does not have any meter indicates the output. So actually here we have to see output on the CRT screen. So we cannot measure values in the with the help of meter. So whereas in harmonic distortion analyzer the output is indicated in a meter. So in the harmonic distortion analyzer the output will indicate in meter in the harmonic distortion analyzer. So actually your analyzers are the combination of the some tuned circuit and rectifier circuit. So actually a rectifier circuit having one meter also. Now by the changing fundamental frequency with the help of tuned circuit, so you can observe variation in the rectifier circuit because of a rectifier also having so one meter. So with the help of that meter, so you can observe output of the analyzer. So last one, in spectrum analyzer are used to display the spectras of different modulations such as amplitude, phase, frequency modulation. So actually with the help of spectrum analyzer we can display values of the, that means different modulations such as amplitude, phase, frequency modulations. So whereas in harmonic distortion analyzer they cannot be used to measure frequency stability and spectral purity of signal sources. So here harmonic distortion analyzer, that means with the help of harmonic distortion analyzer we can measure fundamental frequency values. So these are the differences between spectrum analyzer and harmonic distortion analyzer. So next one, differences between wave analyzer and harmonic distortion analyzer. So actually already you know the idea about wave analyzers. Generally we are having two types of wave analyzers. So based on frequency selective values we can call as the frequency selective voltmeter that will be operate some frequencies in the form of 20 Hz to 20 kHz, and the second one is the super heterodyne voltmeter. With the help of heterodyne voltmeter you can measure frequency ranges from 20 kHz to 18 MHz. So here with the help of this type of analyzer. So you can study wave analyzer and harmonic distortion analyzers. Both are the analyzers. So actually, here the first difference in wave analyzer, actually your wave analyzers are designed to measure the relative amplitude of each harmonic or fundamental component separately. So whereas in harmonic distortion analyzer, harmonics are designed to measure the total harmonic content present in a distorted or complex waveform. So actually here every wave having some combination of the harmonic distortions. So harmonic components. So now to find total distortion in the wave, you have to consider all harmonics, all harmonic components. So actually here every complex waveform having is the combination of the different values of the harmonic components. Finally combine them, so we'll get the total harmonic value. The second one, so the wave analyzers indicate the amplitude of a single frequency component. So actually with the help of wave analyzer, you can measure only fundamental frequency of the component. So by the changing value of LC, you can vary the fundamental frequency also. So whereas in harmonic distortion analyzer, they do not indicate any frequency or amplitude component. So here we cannot indicate any frequency value because of this is the combination of the number of harmonic components. So that is the reason do not indicate any frequency amplitude component. So next, the third one, these are also known as, so actually these are name run to measure amplitude of frequency component within the range 10 to 10 Hz to 40 megahertz. So whereas in harmonic distortion, this can be operated within a band of 5 Hz to 1 megahertz. So your fourth point, so in wave analyzer, so these are the also known as frequency selective voltmeters or selective level voltmeters or carrier frequency voltmeters. So already you know the idea about types of wave analyzers here. So we are having two types of wave analyzers. One is the frequency selective voltmeter and other one is the heterodyne voltmeter. So whereas in harmonic distortion analyzer is generally known as the distortion analyzer. So with the help of this analyzer, you can finally determine the value of the distortion. And fifth one, in wave analyzer, there are used to set a tuned filters and a voltmeter. So these can be used to along with the frequency generator. Whereas in harmonic distortion, this can be used along with a frequency generator. And sixth one, wave analyzer provide very high frequency resolution, whereas in harmonic distortion analyzer measure quantitative harmonic distortion very accurately, very accurately measure. So quantity harmonics distortion very accurately. So now last point in wave analyzer. So this can be used for electrical measurements, sound, vibration, noise measurement in industries. So actually these are the uses of the wave analyzer. With the help of wave analyzer you can measure sound, vibration, noise measurement in industries. So whereas in harmonic distortion analyzer, this can be used to measure frequency stability and spectral purity of the signal source. This can be used to measure frequency stability and spectral purity of signal source, because of with the help of tuning circuit and rectifier circuit you can change position of the fundamental frequency also. So these are the differences between wave analyzer and harmonic distortion analyzer. Next I am going to explain differences between spectrum analyzer and wave analyzer. So actually every analyzer having some characteristics. Now I will compare characteristics in spectrum analyzer and wave analyzer. So first I will take first characteristic as frequency range. This frequency range is typically from 1 megahertz to 40 gigahertz. So whereas in wave analyzer its frequency range typically below 50 megahertz. So these are the frequency ranges in spectrum analyzer and wave analyzer. Come to the accuracy. So accuracy, signal frequencies cannot be measured accurately. So with the help of spectrum analyzer, signal frequencies cannot be measured accurately. Whereas in wave analyzer, signal frequencies can be measured very accurately. So actually your spectrum analyzer will express values in the form of amplitudes. That's the reason. So your frequencies cannot be measured accurately. So whereas in the wave analyzer, signal frequencies can be measured very accurately. Because of here you will take individual attention, harmonic by harmonic. So that is the reason you will get measured values very accurately. So last one, display. So actually in spectrum analyzer, to display any output on CRT screen. So here spectrum analyzer in which voltage is displayed on the vertical axis and frequency on horizontal axis. Actually in CRT that means CRO, with the help of CRO you can express, you can display amplitude values on y-axis, time on x-axis. But in spectrum analyzer in which voltage is displayed on the vertical axis, frequency voltage displayed on the vertical axis and frequency on the horizontal axis. So whereas in wave analyzer, in place of CRT, wave analyzer consists of indicating device. Hence an integrated view of a spectrum is not possible because of Actually a wave analyzer having as only two components. One is the LC circuit using for the purpose of tuning fundamental frequencies to see output with the help of rectifier circuit. Because of your rectifier circuit is the combination of the bridge and some detector. Some detectors. With the help of detector, we can find values in the voltages, so like that. So that's the reason. So with the help of wave analyzer, so we cannot get any spectrum. That is the reason spectrum is not possible. Okay, these are the differences between spectrum analyzer and wave analyzer. So I have completed unit 2. So before going to start unit 3, once again I will recall this unit. Once again I will give overview of the unit 2. So already I have mentioned some agenda of the unit 2. Actually this having 19 topics. So actually first topic wave analyzer. Already you know the classification of the wave analyzers as two. First one frequency selective wave analyzer, and second one is heterodyne wave analyzer. So actually in agenda, two three are the part of the wave analyzer. And the fourth one, distortion analyzer. And fifth one, methods of measure harmonic distortion analyzer. So actually here we are having two three methods to find harmonic distortion. One is the restive method, and second one is the Wien-Bridge method, and third one is the T-network method. So next topic, power analyzer. So with the help of power analyzer, you can measure power problems in the industries. So accurately you can monitor power distribution in the industries. So next topic, capacitive and voltage analyzer. So with the help of capacitive and voltage analyzer, so you can measure values of the capacitive value in time, capacitive value in voltage. So next one, spectrum analyzer. So with the help of spectrum analyzer, you can display frequency, amplitude, so values on y-axis and x-axis. Here you will get output in the form of a graphical representation. So this is the function of the spectrum analyzer. Here, so we can observe two types of spectrum analyzers using filter bank and RF spectrum analyzers, so like that. So next one, logic analyzer. So actually here we have two types of logic analyzers. So one is the logic state analyzer and other one is the logic time analyzer. So with the help of these analyzers, you can see output in the form of state analysis and time analysis. So your state analysis means this is the synchronization process, time analysis is asynchronous type of process. So next one, signal analyzer. So already you know the idea about some signal analyzer. With the help of signal analyzer, so we can estimate values of the signals. So according to our previous explanations, we have signal analyzer as in the form of oscillator and attenuator. That means here signal analyzer are the fixed and variable frequency AF oscillators. So fixed means you have to set some values. So with the help of oscillator and attenuator, so you can do like this. Variable means you have to change the position of the frequencies. So actually next topic here, basic sine wave generator. So actually your basic sine wave generator is the combination of the oscillator and attenuator. So with the help of oscillator you can set the frequency and you can generate sine wave. So generally your oscillators are the sine wave generators. So with the help of sine oscillators you can change the shape of the waves also. That means here with the help of functions which you can change sine wave in the form of square wave also, depending of operation. So you can do like that. So whatever you need, you can draw from the circuit diagram. So here generally sine wave generators are the oscillators. That means with the help of Wien bridge oscillator you can generate sine wave. So now by the using shaper circuit, the output of the Wien bridge oscillator you can change as square wave. So here square wave will maintain duty cycle as 50%. To get square wave, pulse wave, so here you have to change position of the duty cycle between 50 to 90%. So next one, function generator. With the help of function generator you can generate waves in the form of sine wave, square wave and a triangular wave. So next one, sweep frequency generator. With the help of sweep frequency generator you can generate sweep voltages in the form of sawtooth wave. So next one, arbitrary wave generator. So here by using this generator you can measure arbitrary values, arbitrary sequence values with the help of meter. So finally with the help of microcontrollers, with the help of finally you can see output on display. So next, random noise generator. So here we have to take noises randomly, that may be in the form of white noise, pink noise and so USRC noise. So with the help of that noises you can measure our required noise according to our requirement. So last one, video pattern generator. So with the help of video pattern generator we can servicing TVs and some audio equipments also. So these are the overview of the unit 2. So in the next video I will explain unit 3. So thank you.